Krishna.
Okay guys, today I am going to start the electrochemistry. Okay, in electrochemistry, the major part is the Faraday's laws of electrolysis. Now I am going to teach Faraday's first law. So there are two Faraday's laws are there. So one is the Faraday's first law and another one is Faraday's second law. So Faraday's first law. So what is Faraday's first law? The amount of substance deposited or liberated, or the amount of substance deposited or liberated at electrodes is directly proportional to quantity of charge or quantity of electricity passes through it. What is the statement? The amount of substance deposited or liberated or dissolved at electrodes is directly proportional to the quantity of electricity passes through it. Quantity of electricity passes through it. So I am repeating again. What is the amount of substance deposited or liberated or dissolved at electrodes is directly proportional to the quantity of electricity passes through it. So this is the Faraday's first law statement. Now according to that statement, what is the M is directly proportional to Q. Here what is M? M is the mass of the substance deposited or liberated or dissolved. Here deposited means if it is a solid, it is deposited. If it is gas, it is dissolved. Or if it is the liquid, the dissolved. So M is directly proportional to Q. Here Q is the quantity of charge in coulombs. So okay, then M is equal to some proportional constant small e into Q. Say equation 1 here. Here what is the small e? Small e is electrochemical equivalent. Here small e is electrochemical equivalent. Electrochemical equivalent, right? Look at now here, what is small e is equal to M by Q, right? Here M is equal, here Q is equal, suppose Q is equal to 1 coulomb, then small e is equal to M. Then how to define small e, electrochemical equivalent? That means the amount of substance deposited or liberated at electrode by passing 1 coulomb of electricity. Is it clear? So what is the definition of electrochemical equivalent? Listen once again, I am repeating. So the mass of substance deposited or liberated at electrodes is equal to, the M means by passing 1 coulomb of electricity. That means amount of substance deposited or liberated at electrodes by passing 1 coulomb of electricity. That is the electrochemical equivalent, right? Now from equation 1, so there is M is equal to, instead of capital E you can write small e, you can write capital E by F into Q. Or here what is E by F means, since small e is equal to capital E by F, right? Okay, again that is M is equal to capital E by F into I into C. Again here since Q is equal to I into T. Here what is Q? Quantity of charge in coulombs, but Q is equal to I into C. Here I is current in amperes, T is time in seconds. What is I is current in amperes, T is time in seconds. Of course, in problems they will give hours or minutes, whatever it is, but always you have to convert into seconds only. So in Faraday's first law, the time in the questions they will give minutes or hours, but always you have to convert into seconds while doing calculations, right? This is the Faraday's first law formula. Come on. Once again, repeating what are the terms explanation here. M is mass of the substance deposited or liberated. Here E is chemical equivalent. E is the capital E is chemical equivalent. F is Faraday. F is Faraday. I is current in amperes. C is charge. That means I here T is the time in seconds. Q is equal to I into T. So T is the time in seconds. This is Faraday's first law, right? So I am repeating once again. Follow this one. Faraday's first law. What is Faraday's first law? The amount of substance deposited or liberated or dissolved at electrolysis at electrodes during the electrolysis is directly proportional to the quantity of electricity passes through it, right? That is a statement. So based on statement, what is the mathematical expression? M is directly proportional to Q. Here M is equal to some proportional constant small e into Q. Here small e is electrochemical equivalent. So how to define the electrochemical equivalent from that equation? E is equal to M by Q, right? Here M, suppose if Q is equal to 1 coulomb, if Q is equal to 1 coulomb, substitute in this equation, then E is equal to M. So how to define this M? So that is small e can define as, so electrochemical equivalent is nothing but mass of the substance deposited or liberated by passing 1 coulomb of electricity, right? So that means how to define? What is the definition of electrochemical equivalent? The mass of substance deposited or liberated at electrodes by passing 1 coulomb of electricity. So from that equation extended, so M is equal to, we know that electrochemical equivalent is equal to chemical equivalent by Faraday. Here F is the Faraday. So what do you mean by Faraday? Faraday means charge carrying by 1 mole of electrons. Faraday means, I am writing again. So here Faraday means charge carrying by 1 mole of electrons, right? 1 mole of electrons. Charge carrying by 1 mole of electrons. So look at now. Faraday. So what is the charge carrying by 1 mole of electrons? That means, you know, mole, Avogadro number, right? What is the charge of the electron? 1.602 into 10 power minus 19 coulombs, right? Into Faraday means Avogadro number, that is 1 mole means Avogadro number, that is 6.023 into 10 power 23. So by multiplying these two values, we will get 96,500 coulombs. 96,500 coulombs. Therefore, from this equation, the molarity, that is mass of the substance deposited or liberated is equal to, then what is the capital E divided by 96,500. Instead of Faraday, you can write 96,500 coulombs into I into T. This is the main formula to calculate number of numericals from Faraday's first law. So this based on some more extension also, one more formula also we have to derive from this equation. So what is that? We know that mass by equivalent weight is nothing but number of gram equivalents, right? Therefore, number of gram equivalents is equal to the E chemical equivalent is bring it this side, then M by capital E is nothing but number of gram equivalents, that is equal to I into T divided by 96,500 coulombs. This is also another formula to calculate the number of gram equivalents. This is the Faraday's first law. Okay, clear? So understood or not? Say yes or no. Okay, fine. Right. Now, this is the Faraday's first law. Okay, some numericals also you can solve based on this formula. Suppose I am giving one numerical, just you can identify this, and calculation also. We do the calculation. So 9.65 amperes current passed through aqueous CuSO4 solution for 40 minutes and 40 seconds. 40 minutes and 40 seconds. So calculate the amount of Cu deposited at cathode, right? So question read now, all of you. So what is the question now? So 9.65 grams, 9.65 amperes, 9.65 amperes current passed through aqueous copper sulfate solution for 40 minutes 40 seconds. Calculate the amount of copper deposited, right? So look at now. So what are the given values? 9.65 amperes means current is given. Again time 40 minutes and 40 seconds, you have to convert into total seconds only. Time also is given, right? Now E, we know that E, that is the equivalent mass of copper. You know that atomic number of copper is 63.6 by 2 because copper is bivalent. So that it becomes 31.6, right? So directly you can substitute this formula in values in this formula. So look at now. Okay, this is the formula, right? So mass of substance or copper deposited is equal to equivalent weight. So 31.6. Already you know, directly I am substituting the value. So next 96,500 coulombs into what is the current is given? 9.65 amperes is given. Time calculate now here. What is the 40 minutes means 40 into 60? That is 2040 seconds. Again plus 40 seconds you can add it now. It becomes 2440 seconds time. So always convert into seconds only, total time, right? This is the values. Now here 0 cancel, right? So otherwise 9.65 here how many times will comes? So almost 9,650. So 1000 times it will cancel, right? 1000 times. So 244 by 1000 means it becomes so 31.6 into 0.244. 0.244. Okay, by multiplying 0.2 here 31. So almost 64 point something like that. Approximately you will get it. Otherwise you can calculate and solve it this. Okay. So around 60, not 60, it's only 6 grams like that. Okay. Otherwise calculate it 2, 6. So 22, 4. Again 2, 4, 1. 4, 3, 6. 4. 3 is 12. Okay. Same thing now. 4, 6, 2, 1. Next 2, 2, 12. Okay, 2, 3. Next 6. By adding this 4, 10, right? So 10, 11. Next 5, 7. This is 7. So point. What is this value? Total value 7 point. How many of 4 digit? After 4 digit, you have to put the decimal. That it becomes 7.7104 grams. This is the value. How much copper is deposited at cathode? 7.7104 grams copper deposited when 9.65 amperes current passed through aqueous copper sulfate solution for 40 minutes and 40 seconds. So like this. So not only this copper, sometimes the weight of copper they will give, but time you have to find the time, or sometimes current will loss. So multiple formulas, by using this formula in multiple way, you have to calculate the problems. You have to calculate the number of problems. This is the Faraday's first law. So understood or not, boys? Okay. Now come to Faraday's second law. Faraday's